So hi guys, welcome back to my channel. So today I'll be solving this GFG problem, which is Santa Banta. The difficulty is marked as medium. So before that, the code is looking very big, okay, and the problem statement is also very big, but believe me, it's the most simplest problem, okay. So the only thing which you have to keep in mind is have some patience, and after I explain the code or explain the problem, you don't even need to look at the code. The code will become cakewalk for you all. You all can write it by your own. So let's try to read the problem and try to approach this. Okay, so Santa is still not married. He approaches a marriage bureau and asks them to hurry the process. The bureau checks the list of eligible girls of size n, means the bureau has n number of girls, and he hands it over to Santa. Now Santa, being conscious about his marriage, and he wants to find a girl with maximum connections. Just focus it. He wants to find a girl with maximum connections so that he can gather more information about her. Now, in this problem, there are two parts. There are two things that we have to solve. So the first part is he looks to figure out the maximum number of girls who know each other to achieve the above purpose. Okay, so this is the first part. Second part, in order to finalize the girls, he need to find the kth prime, means where k is equals to largest group of girls who know each other. This is not of use, so I'm not reading this line. Okay, so moving further, in case number of connections is 0, print -1, and here the connection between girls is represented as 2D array, just like this, like G, and the dimension is m into 2, and where the m is the number of connections, means whatever connections it given in the form of array, the connection is 6. So 1 2 3 4 5 and 6. Okay, so let's move forward. So note, suppose girl A knows girl B and girl B knows girl C, then girl A also knows girl C. It is mutual friendship, means if A knows B, B knows C, then C also knows A. Right, now consider 1 as a composite number. Okay, so pre-compute is already given in the boilerplate. We just have to complete the pre-compute, and it is called in the driver code. We don't need to worry about this. Now let's understand the problem. Now this is the theory part that we have read to get a little bit idea what question is trying to say, but actual understanding always comes from the test case. Okay, so here is the connection. Okay, so first thing is we are given 10 girls. Okay, 6 connections, and here are the connections 1 2 3 4 5 and 6, and we all know that if A knows B, B knows C, then C also knows A with mutual friendship. Okay, so this is clear. Now let's see, if 1 knows 2, so 1 knows 2, 2 knows 3, 2 knows 3, 3 knows 4, 3 knows 4, 4 knows 5, 4 knows 5. Now here it breaks. Now 6 knows 7, 7, 9 knows 10, 9 knows 10. Okay, but we have 10 girls, so it's still 8. 1 2 3 4 5 6 7 8 9. So 8 is still missing. So the girl number 8 is here with no connections. Okay, so we have reached till here. So what we have to notice here, so this is the first group, this is the second group, this is the third group, and this is the fourth group. As mentioned, first group, second group, third group, fourth group. And what we have to find, the size of the first group is 5, second group is 2, third group is 2, fourth group is 1. Now the maximum, read the problem again. Find a girl with maximum connections so that he can gather more information, means we have to find a girl who has maximum connections, or the group of girls that have maximum connections. So this group of girls has maximum connections of 5. Okay, so the maximum connection among all the group is 5. Now first part of the problem is this much. We have to find the group who is having maximum connections, and we have to return that. Okay, so 5, the group size is 5. Now the second part is saying that in order to finalize the girls, he need to find the kth prime. K is equals to largest group of girls who know each other. So K is equals to, means this is equals to K, means the largest group of girls who know each other. What we have to find? We have to find the kth prime, means 5th prime number in the number list. Okay, so the 5th prime number in the number list given here is K is equals to 5, and the 5th prime number is 11. Okay, so I hope the question is clear. Means 5th prime number we have to find, which is 11. So let me repeat it once again. What we have to do, we have to see the connection of all the girls, and we have to make it in the groups, and whatever the maximum size of the groups, that number we have to find the prime number. Means here 5, so 5th prime number is 11. Okay, so I hope the question is clear. So let's try to approach this, and let's see how we can solve this problem. Now there are two things that we have to know to solve this problem. So the first thing is number of elements in a group which is maximum, means we have to find the groups which has the maximum number of elements. So this is number of elements in a group which is maximum. And the second thing is kth prime number. So the first part is solved by the famous problem number of islands. There is a slight change and we'll be able to cover this part. Second part is covered by this one, Sieve of Eratosthenes. Okay, why Sieve of Eratosthenes? Because the time complexity to find the kth prime number here is n log of log n. Okay, so this is less, so we'll be using Sieve of Eratosthenes to find the kth prime number. And number of elements in group which is maximum can be solved by number of islands. So let's see how we can handle this. So now here is the adjacency list. So 1 knows 2, 2 knows 3, 3 knows 4, 4 knows 5, 5 knows 4. Okay, so 6 knows 7 and 7 also knows 6 because there is a mutual friendship. 8 knows no one, 9 knows 9 knows 10 and 10 knows 9. Okay, so this is the adjacency list which we can which we have drawn from the like connections array, okay, from G. Now what we have to do, we'll be slowly iterating the adjacency list and we'll find that what is the maximum size that we can achieve. Okay, so here is the visited array and here is the adjacency list or the connection of girls. So slowly we'll be visiting one by one and marking it as visited. So starting the count is, okay, so we'll be starting from 1. Okay, so we'll be making our count as 1. Okay, and marking 1 as 2 that we have visited. From 1 where we can visit to 2. Okay, so we can visit to 2. Now 2 is not visited yet, so mark it as 2, increase the count to 2 and move further. We'll be moving further to 3. So from 2 we can move to 1 and 3, but 1 is already visited, so we'll be moving to 3. 3 is not marked as 2, mark it as 2, increase the count to 3. Now from 3 where we can visit to 2 and 4. So 2 is already visited, but 4 is not. You can see 2 is visited, 4 is not. So we'll be moving to 4. Now mark 4 as 2, increase the count to 4. Now from 4 where we can visit to 3 and 5. 3 is already visited, 5 is not. So let's move to 5. But before that, mark 5 as 2 and increase the count from 4 to 5. Okay, done. So we can see here that from 5 where we can move 4 and nothing. So 4 is already visited, so just get back. From 4 where we can visit 3 and 5. 3 and 5 we have already visited, so let's get back. 3 where we can visit 2 and 4 already visited, get back. From 2, 1 and 3 already visited, get back. Now we got a group of girls which have the connections. Number of girls present in that group is 5. So let's store somewhere that maxi 5. Till now we got one group, that is 5. Now next thing, we have to iterate from 6. Okay, from 6 where we can visit to 7. Okay, mark before that move count to 1 because 6 we are visiting, 6 marking it as 2. Now where we can visit 7. Okay, 7 is not visited, let's move to 7. Mark 7 as 2, increase the count from 1 to 2. Okay, so from 7 where we can visit to 6, but 6 is already visited and no more connections. So let's get back to 6. And from 6 where we can visit 7 and no more connection, so 7 already visited. So we got one more count, one more group size which is equals to 2. Let's compare the maxi. Okay, so maxi we have 5 and we got new group which is of size 2. So we have to update? No, we don't need to update this. Okay, so let's move to next group which is 8. Okay, so 8, marking 8 as 2, making the count to 1. Okay, let's see from 8 where we can visit, nothing. So let's move back. So the count is 1. No need to update because our maximum size is still 5. Now let's move to 9. Okay, from 9 where we can visit 9, first of all marking 9 as 2, making the count as 1, and from 9 we can visit to 10. Okay, we can visit to 10. We have visited 10. Now marking 10 as 2, increasing the count to 2. Now whether we need to update the maxi? No, there is no need to update the maxi. So after completing all the elements or after visiting all the girls, we know that the maximum number of connections or maximum members in a group of girls is of size 5. Now we have solved the first part, which is like finding the members of group which is of maximum size. So we got 5. Now what we have to find, the second part is we have to find the like kth prime number. Okay, so let me explain you what is Sieve of Eratosthenes and how we are able to solve this, like how we are able to find the kth prime number by using this sieve of Eratosthenes. So let me write. Let's say we have to find all the prime numbers that we can find. Okay, so 1 is not a prime number, so in excluding 1, let us start from 2. Okay, what we are going to do here, so initially we assume that all numbers are prime. Okay, so listen it very carefully. Sieve of Eratosthenes is very important concept. It is very useful in many of the problems. Like it doesn't come as an individual problem, but it helps to solve many problems. So let's see. Initially, what we are going to conclude that all the numbers that we have declared is prime. Okay, now we have to iterate one by one. Okay, so 1 is not a prime number, so let's exclude it. We are starting from 2. What we are going to do is we are going to mark false all the multiples of 2. So 4, let's mark it as false. Let me one by one crossing it. 4 is false, 6 is false, 8 is false, 10 is false, 12 is false, 14 is false, 16 is false, 18 is false, 20 is false. Means we have marked all the multiples of 2 because we all know that the prime number has a multiple of itself and 1, nothing other. But 2 is the multiple of 6, so we have removed it. Now we have to move to 3. So we are moving to 3. Why 3? Because if it is the multiple of any of the number, then previous to that number has already cancelled it. I'm repeating it again, that why we have directly jumped to 3, because if 3 contains the multiple of any of the number previous to this, then it would have cancelled. So let's move to 3 and cancel all the multiples of 3. 6 is already cancelled, 9, let's cancel it, 9, then 12 already cancelled, 15, let's cancel it, 18 is already cancelled. So let's move further. 5. Why we have jumped directly to 5? Because if 5 is not a prime number, then it would have cancelled by any of the number which is coming before 5, but it is not cancelled, so we'll be taking it as a prime number. Now excluding all the multiples of 5, so 10 already excluded, 15 already excluded, 20 already excluded. Now let's move to 7. Okay, so why we have directly jumped to 7? If 7 is not a prime number, then same as it would also have cancelled with all the previous elements that we have iterated through. So 7 to the 14 already cancelled, 7 to the 21 not included in the list. So let's move forward, which is 11. Okay, so 11. Why 11? Same answer. Okay, so excluding all the multiples of 11, 21, 11 to 22. 22 is not in our list, so let's move further. 13 to the 26 not included in the list, so let's move further. 17 and then 19. Okay, so we got all the prime numbers from here. So let's calculate the fifth prime number. So this is the first one, this is the second one, this is the third one, this is the fourth one, and this is the fifth one. Okay, so if our value k is equals to 5 and we have calculated that our fifth prime number is 11, so you all can see here our test case is returning 11. So the fifth prime number in the number list is 11. So I hope this is clear. So the first part is clear, like number of elements in a group which is maximum, and the second part is kth prime number, okay, by using sieve of Eratosthenes. So let's move directly into code. Okay, so what we are doing in the code is, so first of all we are declaring an unordered map in which it is in which it is finding the adjacency list. Okay, so now this is the way we are going to find the adjacency list. Why? Because 1 or 2 we are taking u as 1 and v as 2, and adjacency of 1 dot pushback 2 and 2 dot pushback 1, so that we are getting 1 has a connection with 2, 2 has a connection with 1. Okay, so now let's move forward. Now we are declaring a vector visited to know that what are the elements that we have already visited, so that we don't need to visit again in future. Okay, so let's move forward. Initially our candidate is 1. Why? Because so each and every individual has this one group. Okay, so we have declared candidate as 1. Now we are slowly iterating. So from 1 to n means from 1 to n we have to visit all the numbers. That's why the size of the visited is n plus 1. Okay, so if the number, like the number of element is not visited, then we have to declare the count as 0. It means the count as 0 and call the DFS, depth first search, that we have, that I have iterated and explained. So call the DFS, and then after we get the number of count, means what are the members in the group. So after getting the count means the number of members in that particular group, we are updating the candidate, because we want the maximum number of candidate in a particular group. So after that, what we are doing, so we are given that if in case number of connection is 0, it means that the only person is there in the group, we have to return -1. So if candidate double equal to 1, we are returning -1, and else we have to return the fifth prime number. Let's say we have to return the kth prime number. So what we are doing, prime candidate -1, because candidate is storing 5. Okay, so let me tell you why we are doing candidate -1, because 2 is prime, 3 is prime, 5 is prime, 7 is prime, and 11 is prime. So this is 0, this is 1, 2, 3, 4. So actually the fifth prime number is stored in fourth index. So that's why we are doing candidate -1 in prime. Now let's see the DFS code, what we are doing, and then I'll be explaining the Sieve of Eratosthenes code. Okay, so in DFS code, what we are doing, we are sending the U, we are sending the count, we are sending the adjacency list, visited vector. Now every time we are marking the visited U as true and increasing the count. Next, what we are doing, we are making a for loop on adjacency list, that what are the number of candidates, we can visit from that particular element. It means I got 2 and 4. So if 2 is not visited, then I have to visit 2. If 2 is visited, then I have to visit 4. Okay, so here is the check, that if not of visited, then again call the DFS, then again mark visited and give the count as ++, doing ampersand because it will save the count. Okay, so now let's move to pre-compute part, means it is the Sieve of Eratosthenes. So it is the Sieve of Eratosthenes code. What is the time complexity of Sieve of Eratosthenes code? I have already explained, big of n log of log n. Now I have declared prime, and to be on the safer side, the constraint given in the question is n is 10 to the power 5, m is 10 to the power 5. So to be on the safer side, I have taken n, the size, as 10 to the power 6 and plus 10. So initially what I am going to do, I will be marking is prime of 0 as false and 1 as false, because 1 is the composite number. Now, so as I have explained, I will be iterating from 2. Okay, so what I am doing here is, for I am looping from 2 to 10 to the power 6 plus 10. I am making a check here, is prime I is equals to true. Initially what I have done, I have marked all the elements as true and except 0 and 1. So 2 is already marked true. So it will enter inside this prime dot push I. I'll be pushing I into the prime as 2 and then move to next. So I am iterating from j is equals to I into 2, means 2 into 2. 4, from 4 I'll be iterating, and every time I'll be adding I means 2. So why? From 4 I'll be starting. Okay, I'll be marking false. I'll be marking is prime as false from 4, and every time I'll be incrementing it by I. So 4 I have marked false, I plus I. So 6 I have marked false, then plus I. 8 I have marked false, then plus I. Then 12 I have marked false, then plus I. Same, I am doing it again and again. And then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 has marked false. Now I'll be moving to 3. So what I'm doing for 3? For 3, I'll be starting from 6. Why? Because I int j is equals to I into 2, means I will become 3. 3 into 2 will become 6. And every time I'll be incrementing I. That means 3. So from 6 I'll be starting, I'll be increment 3, then it will reach to 9. So 6 I'll be marking as false, then 12 I'll be marking as false, then 15 marking false, 18 marking false. So similarly this will go on, and in prime what I'll be storing all the prime numbers, so that it will be easy for me to calculate. I'll be simply giving prime candidate -1, which is 5 minus 1, 4. So fourth index I'll be getting it as 11. So I hope the code is clear. So now let's run the code. So I hope this will pass. Okay, so let's submit it. Okay, so you all can see that the code has passed. So I hope I was able to explain the problem in an easier manner, because this is the Sieve of Eratosthenes code that I have explained. This is the DFS code, standard DFS code that I have explained, and how we are solving this problem. Like, this is the first part that we are doing to find the candidate, like what is the maximum size of a particular group that we can find. This is, we are returning the kth prime number. Okay, so I hope this is clear, and thank you for watching and having patience. So thank you.